All right, welcome to this explainer. Today we're doing a really deep dive into the modern battlefield, looking specifically at how extremely high-pressure environments are forcing technological innovation at a pace that, honestly, we've just never seen before. It's essentially a real-world Red Queen's race. You know that concept, right? Where you have to run as fast as you absolutely can just to stay in the exact same place. Well, in modern conflict, if your tech isn't evolving daily, it's already obsolete. So, let's just dive right into it.
To really understand why this is happening, we have to look at this extreme cost asymmetry that is just completely upending traditional military economics. Think about this for a second. A $25 million modern attack helicopter, something heavily armored, packed with state-of-the-art tech like the Mi-28NM or the K-52, can literally be taken out by a commercial FPV drone that costs maybe $500. Kinetic armor just doesn't guarantee the survival of multi-million-dollar assets anymore. The whole traditional paradigm of air superiority, yeah, it's been flipped completely on its head.
But as you'd expect, this massive advantage for the $500 drone has triggered an equally extreme counter-reaction. I mean, if you can't afford to shoot down every cheap piece of plastic with $1 million missile, what do? Well, you weaponize the air itself. You saturate the entire environment with invisible electromagnetic interference. So, the big question we're exploring today is, how on earth do forces operate when the very spectrum they rely on is actively hostile?
Which brings us to Section 1. Electronic warfare and spectrum suppression.
This right here is the first massive challenge, an invisible physical wall of electromagnetic noise that just blankets the operational area. Now, at a strategic level, you've got these massive systems like the Krasuka 4, capable of blocking low Earth orbit satellite comms and radar across a 200-kilometer radius. But honestly, the real threat to drones is highly tactical. We're talking about systems like Fulnores, which are mounted straight onto tanks or hidden in trenches. They create this localized omnidirectional noise bubble, basically a defensive shield a few hundred meters wide that completely suppresses incoming control links. The operator's screen, it just instantly cuts to static.
Now you might be wondering, why don't they just crank up the signal strength on the drone's remote control? Well, that brings us to a fundamental physical limit, the inverse square law of radio frequencies. Signal strength drops exponentially the further it has to travel. Because the defender's jammer is sitting right next to the target, it only needs a tiny fraction of power to completely drown out an operator transmitting from a few kilometers away. You simply cannot win a brute force power struggle against physics.
Moving on to Section 2. GNSS jamming and navigation denial.
So, if you can't just block the signal, what's the next move? You attack the actual coordinates the drone uses to figure out where it is. We're all familiar with jamming, just blasting raw noise. But spoofing is so much more dangerous. Spoofing is when you transmit fake satellite ephemeris and timestamp data. It doesn't loudly block the signal. Instead, it quietly sneaks in and feeds the drone's internal math, specifically its EKF3 navigation filter, totally fake coordinates. The drone thinks it's flying straight and level, right? But the spoofing has actually tricked it into steering directly into a mountainside or straight into an air defense trap. It's a silent, lethal manipulation of reality.
So how do you survive when you literally can't trust the satellites in the sky? Engineers are rapidly pivoting to zero-signature passive modes. First up is visual inertial odometry, or VIO. This is where the drone uses its onboard cameras to look at the ground, pick out physical features, and compare them to preloaded offline maps to navigate completely without GPS. For ultra-low altitude stuff, they're using height map gradients and particle filters, basically matching the 3D shapes of trees and buildings to digital elevation models. And then, on the hardware side, you have CRPAs, Controlled Reception Pattern Antennas. These are just brilliant. They're smart antennas that actually detect where the jamming signal is coming from and dynamically create an electronic null, like a targeted blind spot, in that specific direction so the true satellite signal can still poke through.
Let's look at Section 3. The rise of fiber optic drones.
When the electronic warfare gets so dense that absolutely none of those radio or GPS tricks work, we're seeing a crazy pivot away from vulnerable radio frequencies, right back to physical tethers. RF signals can be jammed, spoofed, and tracked to find the operator. But fiber optic cables, they transmit light pulses. They have absolutely zero radio frequency signature. It is physically impossible to jam them with electromagnetic noise. They offer absolute 100% electromagnetic immunity. And the scale of this is just wild to think about. We're talking about drones taking off and unspooling anywhere from 10 to a staggering 65 kilometers of ultrafine polymer or glass fiber mid-flight.
Because it is a direct, physical connection, the operator gets zero latency, totally uncompressed, high-def video right up until the exact moment of impact. The drone acts like an absolute ghost, slipping right past the most advanced electronic warfare bubbles on the planet.
But, of course, that absolute immunity comes with some pretty severe constraints. First is the economics. Because of massive battlefield consumption and, believe it or not, competition with global AI data centers, the price of these specialized spools has spiked from about $300 to over $2,500 each. Tactically, dragging a physical wire means you can't easily maneuver through complex forests or cities without snapping the line. And ecologically, it's a total nightmare. Every single launch drops miles of this unbreakable polymer spiderweb all over the landscape, tangling up wildlife and ruining farm machinery. It's a localized environmental hazard that's going to stick around for decades.
All right, Section 4, Real-Time Battlefield Data and AI Evolution. All this intense electronic combat is doing something else too. It's supercharging the next generation of autonomous weapons. The crucial thing here is what actually happens when a drone is defeated. The source material refers to this incredibly striking concept, the blood sacrifice of algorithms. In the past, if a drone got shot down, it was just a lost asset. Today, every single downed drone is a highly valuable data point. It provides real-time telemetry, radar frequencies, and failure metrics that are instantly fed right back into the edge AI models. The Defender's air defense network is essentially being used to train the attacker's next wave of algorithms. It's making them smarter with every single loss.
And we're watching this AI mature incredibly fast. Because those comlinks get jammed so frequently, the drone has to be able to finish the job itself, what they call man-out-of-the-loop economy. To try and trick the AI's computer vision, militaries started painting vehicles with these crazy, high-contrast black and white zebra stripes to break up their shapes. But the edge AI is already one step ahead. It uses de-camouflage algorithms that literally just ignore the paint job and look for the unique thermal signature of the vehicle's engine exhaust. Once that heat signature is verified, the AI takes over and executes the final dive autonomously, completely unbothered by jamming or visual tricks.
Which leads us to Section 5, Rapid Iteration and OTA Updates.
In this kind of environment, the ultimate meta weapon isn't a piece of hardware, it's speed. The sheer speed of industrial and software adaptation. The shelf life of tech on the modern battlefield has shrunk from years down to weeks. If an adversary changes their jamming frequencies, engineers have to counter it right now. This has created a frantic 2 to 8 week iteration loop. Frontline operators stream data straight back to defense accelerators. The engineers look at it, rapidly iterate new parts using CNC machining or 3D printing, and push updated code right back out to the field. Maintaining that pace requires a completely agile framework. Forget the old decade-long defense procurement cycles. This new framework relies on localized supply chains and defense accelerators. For example, they're using advanced thermoplastic composites that can be ultrasonically welded in a matter of minutes, instead of baking in massive autoclaves for days. It creates this seamless, high-speed feedback loop from battlefield telemetry straight to the manufacturing floor.
And for the software, they're using a continuous integration and continuous deployment pipeline, CI/CD, exactly like a Silicon Valley tech company. They run massive software simulations, moving from software in the loop to hardware in the loop testing. And once those new frequency-hopping algorithms or AI models are dialed in, they're beamed out via over-the-air or OTA updates using secure Wi-Fi or cellular. Literally in a matter of days, thousands of drones sitting in the field are instantly upgraded with the absolute latest countermeasures.
And this leads us to a pretty profound realization from the sources. The entire battlefield has literally been transformed into a giant, real-time industrial R&D system. We aren't just fighting with ammunition anymore. We are fighting with code. Being able to deploy a software patch to your drone swarm faster than your adversary can update their radar is the brand new definition of air superiority.
Which leaves us with this final thought. We've gone from remote-controlled aircraft that were highly vulnerable to radio noise, to these fiber-optic ghosts, and now to edge AI systems that hunt by thermal signature and update their own software overnight. So what exactly happens to global security when hyper-agile, autonomous, and completely unjammable drone swarms are no longer just an experiment, but the absolute global standard for conflict? It's a fascinating and, frankly, sobering reality. Thank you so much for joining me for this explainer. I hope it really helped you unpack some of the profound technological shifts reshaping our world right now.